sometimes when the science material is pretty hard, or you're looking at a specific question, talking about a specific graph, and with little understanding, it's best to just focus on this graph. What does one do? Graph has lots of information, so does a data table, and it can be overwhelming. To make sure you're not overwhelmed, don't look at the entire graph. Pick a point, any point. That's step one. Step two is, what do I know about that point? Describe it accurately. At 100 degrees Celsius, the thermal conductivity is 4. I'm not sure what W per meters, all of that. Doesn't matter right now. If the temperature is 100 degrees, the thermal conductivity is 4. But there's 4 graphs here. So let's add a little bit. If the temperature is 100 degrees, then the thermal conductivity for rock salt is 4. That's not bad. Let's add one more bit. Let's make a generalization about this graph. As the temperature increases, that is, it goes from 0 to 400, the thermal conductivity for rock salt goes down. It doesn't have to be a radical generalization, but it's got to be something. So the first step, pick a point. The second step, describe it accurately, but it's got to be in a complete sentence. Ordinarily, I just read the x and then the y-axis in that order. If the temperature is 100 degrees, the thermal conductivity for rock salt is 4. The third is make a generalization. As temperature goes up, the thermal conductivity for rock salt went down. Pretty quick. What is the foothold? The foothold is a way to quickly understand an item of information. Pick a point, any point. Describe that point accurately in a complete sentence. Make a generalization. Let's try it again. Boy, you look at this, it's a simple graph. What do I do? Let's pick a point. Step 1, pick a point. Step 2, describe it. At 20 seconds, the temperature is 10 degrees Celsius. At 20 seconds, the temperature is 10 degrees Celsius. What's the generalization? Our generalization might be, for a long period of time, the temperature doesn't change. How about the temperature goes up but then stays constant and then goes up at the very end? You're ready to perhaps answer some questions. Of course, not everything is a graph. What about a table? Pick a point. Describe it accurately. At 18 degrees Celsius, what do I know about this number? I have to look up. At 18 degrees Celsius, the number of peony seeds that germinated at a storage period of 4 weeks was 2. What might be a generalization? As the storage week period increased, so did the number of seeds that germinated. This is like an ominous table. Forget what it looks like. Pick a point. 7.8. 7.8 what? The distance traveled for cadmium was 7.8 centimeters. Distance traveled what? What traveled? Maybe we look in the explanation then. The distance traveled of such and such was 7.8 centimeters for cadmium. What might be a generalization? Is there a relationship in the graph? As the molar mass, we look carefully. As the molar mass went up, so did the distance traveled. That's probably one of the questions. What's the relationship between molar mass and distance traveled? Most important, it takes a body of information, be it a graph or table, and makes it understandable quickly. I use this now as a secondary device to what we already talked about regarding understanding a science passage.